So let's talk about using MLLib with datasets. This is kind of the new way of doing it in Spark 2.0. And going forward, MLLib is moving in this direction. They want you to use DataFrames or datasets as the input source whenever possible. And they actually have a separate API for this using the ML package instead of MLLib. But you can't always frame your problems in the terms of SQL queries or datasets. So the old API is still there and it's still good to understand, but let's talk a little bit about the new API based on datasets. So it does perform better, that's why people are pushing you toward it, and it also lends itself to better interoperability. So not only MLLib is being pushed in the direction of datasets, but so is Spark Streaming, so is Spark itself, and so is Spark SQL, obviously. So if you want to be able to interoperate between these different systems within Spark, using datasets is a good way to hand data in between them if you want to. So again, you need Spark 2.0 or newer to use this, and if you're still using something earlier, then this isn't even available to you. But going forward, this is the way of the future. So it'll make more sense when we look at an actual example. Let's do our linear regression example again, but this time we're going to use the DataFrame-based API in MLLib and see how that works. So let's look, shall we? So let's go ahead and fiddle with MLLib's dataset API. We're going to do exactly the same problem that we did before, where we take that linear regression problem, where we have page speeds and amount spent data and try to fit a line to it. But we're going to do it in a different way. We're going to use the new MLLib dataset API instead. So you can see up here we're actually importing the ml.regression.linearregression and ml.linalg.vectors classes. These are completely separate from the linear regression and vectors and labeled point stuff that we used before from the MLLib package. So important distinction. Before I get too far ahead of myself, I have gone ahead and imported the linear regression dataframe.scala script into my project here. So if you need to go take care of that and import that from the course materials you downloaded earlier in the course, please hit pause and go take care of that right now. And once you're ready to move on, let's talk about this code a little bit more. So we're going to start off like we always do, set our log level, but now instead of using a Spark context, we're going to use a Spark session. And this is basically the API that we use in Spark 2.0 for doing dataset stuff and Spark SQL stuff. So the syntax here should look familiar from our Spark SQL lessons. We're going to call a builder to create a new Spark session with an app name of linear regression df, master of local star, and again, make sure that you comment this line out if you're not on Windows. This is a Windows-specific workaround for an issue in Spark 2.0, and you will need to make sure you have a C temp folder present on Windows. Get or create that session object, and now we have something we can work with. So again, our input data is not in a structured format, it's just a text file, so we first need to impart some structure upon it before we can create a data set out of it. So we're going to take the Spark context, the old school Spark context out of our Spark session and just call a text file on it to create a plain old RDD from our regression.txt data. And once we have that, we can call a map to actually give it some structure. So what we're going to do here is we're going to split it up based on commas. And this little syntax here with the underscore, it's basically a wildcard, so it's sort of a shortcut of saying, instead of saying, x arrow x dot split, you can just say underscore, and it means the same exact thing. So it means for whatever, each individual input coming into your map function, that's represented by the underscore character. So we're going to split that up based on commas. That creates a new RDD, that's comma delimited information. And then we're going to map that in turn to some structured data here. So we're going to extract the first and second columns, which represent the labels and the features of our input data. And the label will just be a double in the first column, and the features will be a dense vector of information, in this case a dense vector that only contains that one value. And this is just the format that MLLib expects. So if you're going to be dealing with this linear regression class in MLLib using DataFrames, this is the format it needs to be in. It's exactly the same format as a labeled point from MLLib, but you can't actually use labeled point from MLLib within the ML library. I think it's kind of a build issue that they had in Spark 2.0, so that might get cleared up at some point. But for now, we kind of have to create our label points the hard way by doing this. So at this point, we have a data RDD that contains two columns, doubles and vectors. So the double is the label and the vector is the feature data. And now we want to convert that to an actual data frame. Now, I have been kind of using data set and data frame interchangeably. I don't want you to get too confused by that. Remember, a data frame is a data set. It's just a data set of row objects. So, sometimes people talk about the data set API of MLLib. Sometimes they talk about the data frame API. More often you hear about data frame because that's kind of the legacy of legacy terminology of Spark, but going forward, I think you'll hear about data sets more often. Anyhow, in this context, it doesn't really matter. We're just going to create a data frame from that data, and here's the syntax we're going to use to actually do that. So first we need to import spark.implicits to actually be able to infer the schema of our data RDD. So it's going to be able to peek inside there and say, oh, okay, I have a double and I have a dense vector of doubles. I can actually convert that to something structured and impart the correct types onto that. The other trick here is actually giving names to those columns. So in a data frame, you want to have names associated with those columns so we can actually do SQL queries on them and refer to them by name. And this is one trick on one way to do it. So before we used case classes to do this sort of a thing, but here's an alternative syntax. We can just create a sequence in Scala of the column names. So we know the first column is label, the second column is features. And then when we call df, we can pass in call names. And again, we have this wildcard character and a star. So that just means we're passing in a list of stuff, a sequence of stuff. Okay, in this case, it's going to be a sequence of column names. It happens to have 2, so that will just map that sequence into the call names of this data frame. And at this point, we have a data frame object called df. All right. Now that we have that, we can actually pass that into MLLib. So let's do something a little bit fancier just to make life a little bit more interesting. If you're not familiar with machine learning, you'll get a little free lesson here. So one way you can evaluate the performance of a machine learning model is a technique called train test. And the idea is that you have a set of data where you have a set of known results. So in this case, we know the actual order amount in page speed for a set of data. What we're going to do is split that data in half randomly. So we're going to take half of that data and put it over here and reserve it for actually building our model. And the other half we're going to reserve for testing that model. So the idea is if you have a bunch of data and you randomly split it up, only use a certain percentage of it to actually create the model itself, you can then evaluate that model based on the other data that you held aside. And since the model had no knowledge of this other data when you were creating it, it's a good way to actually test how effective this model is at predicting data that it hasn't seen before. So that's what we're going to do. So we're going to call random split on the data frame, and we're going to say we want a 50-50 split, and that will give us back 2 data frames that we're going to call training df and test df. So it returns an array of two data frames. In this case, look at that. It's actually calling it a data set of row, which is equivalent to a data frame. And we're going to pluck out the first one and the second one, and we'll call one training df and one test df. And we're going to use that training df to actually build our model with. So we're creating a linear regression model using MLLib with a bunch of standard parameters here. We're going to call that LIR, linear regression. And then we're going to fit that model to the training data that we set aside. Okay, and that's going to be our model. So we have a linear regression model that we can now use to make predictions. So let's do that. What we're going to do here is take our linear regression model and call transform on it using our test data. So what this is going to do is add a prediction column to our test data frame. So our test data frame will now contain the labels that we know, the actual known page speeds or amount spent, the feature data, and the predicted data. So we can now compare the predictions to the actual known values and use that to evaluate our model. So let's do that. Just like we did before, we're going to extract the predictions and labels, and it's actually a lot easier now that we're dealing with data frames. We can just do a select statement and say I want to pull out just the prediction and label columns. And then we're going to transform that to an RDD. That's just mapping those individual columns to doubles. So we end up with an RDD of 2 columns of doubles, the predictions and labels, and then we can just go through and print them one prediction at a time. When we're done, stop the session, and that's it. So let's see if it actually works. I actually already made a run configuration for it, so if you need to take care of that, go ahead and do that right now. And off it goes. Hey, you can see it actually worked. So these should be equivalent results to the earlier example, and you can see that the predictions and the known results are fairly close to each other. So that tells me that our model is actually pretty good. Now obviously there are more principled ways of actually quantitatively measuring how good that model is using things like R-squared or RMSE and stuff, but that's getting beyond the scope of this course. If you want to learn more, go take my data mining and machine learning course if you want to get more depth on that stuff. But there you have it. MLLib in action using the DataFrame API. So that's kind of the future of MLLib. Again, they're trying to tie all of the components of Spark together using data sets. So this is another step in that direction. If you can, think of your MLLib problem in terms of data sets or data frames. You should. it can perform better and will give you greater interoperability and compatibility with other systems. So there you have it. Linear regression using MLLib and DataFrames. Cool stuff.